Hi everyone, this is solution video for Q35 Mathematics question number 34. It's a mark or question. This question is related to numerical analysis. Okay, so let's read the question. So the question reads as follows: we have some alpha, beta, gamma, deltas, few real numbers, and we have some function f such that the quadrature formula, this is the formula, which is exact for all polynomials of degree less than equal to 3. Then we have something which need to be calculated. This 9 times of alpha square, gamma square, beta square, delta square. These are integer anyway, possibly integer, because it's the integer solution possibly. So that we need to figure this out. Okay. So firstly, observe one thing, that it is written that it is known that this equation is exact for all polynomials degree less than equal to 3. That means what? If we consider any polynomial of degree less than equal to 3, then the equation is being satisfied. Okay, so this is the only crucial thing which we are going to use. Okay, so that is the question. So before solving the question, let me display you some course material in terms of NPTEL energy course references. Okay, so here I am displaying the NPTEL energy course references. All the instructor name and the relevant lecture number is mentioned. Also the YouTube video link is mentioned. You can go and watch the corresponding YouTube video. Okay, so this YouTube lecture will cover the desired study material for solving that problem. Okay, so now so now we are going to solve the problem, and for that we need to use some basic facts which we are going to display. Then with those things we are going to solve this problem. So here are the key facts, namely, so first fact is that a quadrature formula is said to have a degree less than equal degree m, which is of exactness, if the integrates exactly polynomial of degree less than equal to. That means what? That a given integration formula is exact for any polynomial degree less than equal to m. That's one thing. And second option is that so those quadrature formula, Harmat type quadrature formula, and the function that can use the values and derivatives at nodes. Okay, and we have some cubic interpolator matching f plus minus 1, f prime plus minus 1, and that gives such a rule on minus 1 plus 1. Okay, but this first one is the most important thing. So technically throughout the solution, this first fact we are going to use, but second fact is also important. You should know the second fact. Okay, but for this solving this problem, this second fact we are not going to use at all. Okay, so now let's solve the problem. See, basically we are going to use the exactness of the given formula for all polynomial degree less than equal to 3. So first what we are doing, we are taking fx equal to 1, and this is a degree 0. Okay, so that formula is exact, and using that formula we are getting minus 1 to 1 dx, that is equal to 2, and that is equal to alpha plus beta exactly equal to 2. Okay, so now, so observe that this is the given formula that has been given in the question. Okay, so what we got is alpha plus beta equal to 2. This is one equation. Now we are putting fx equal to x, its degree is equal to 1. It's a degree 1 polynomial. Okay, now if we integrate minus 1 to 1 x dx, that is 0. Why? Because this x is an odd function, so that's why its integration is 0. Okay, but for that x, f of minus 1 is equal to 1, because f prime is equal to 1 and f of 1 is equal to 1. So using this formula by here, what we're getting, that minus alpha plus beta plus gamma plus delta is equal to 0. Okay, so this is another relation which we got. Okay, now we are putting fx equal to x square. This is a polynomial of degree 2, and the integration minus 1 to an x squared dx equal to 2 by 3. Just you can do it by yourself. There's nothing to do. It's a class 11 12 integration. I'm not doing the integration anymore anyway. And we have this formula f of plus minus 1 is equal to 1, f prime minus 1 is equal to minus 2, f prime 1 is equal to 2. And using these formulas, we get this equation alpha plus beta minus 2 comma plus 2 delta is equal to 2 by 3. Okay. And finally, we put fx is equal to x cube. It's a degree 3 polynomial. And since x cube is an odd function, it's an odd function. So this integration is directly 0. And f minus 1 is equal to minus 1, f of 1 is equal to 1. And we have all f prime plus minus 1 is value. And that value finally gives this equation minus alpha plus beta plus 3 or plus 3 equal to 0. So basically what? So basically we have four equations, this, and this. So observe, we have four variables, we have four unknowns, alpha, beta, gamma, delta, and we have four variables, and we have four equations involving alpha, beta, gamma, delta, okay? And using those equations, we get this alpha equal to 1, beta equal to 1, gamma equal to 1 by 3, and delta is equal to minus 1 by 3, okay? So this is, so this is quite obvious to observe. So you can do the, or you can consider the operations between the equation, and you will finally get these values of alpha, beta, gamma, delta. And if you then finally plug in this value of alpha, beta, gamma, delta here, then you finally get 20. So that is the way. So the point is that since the given equation is given to be exact as for polynomials dimension degree less than equal to 3, so we only used four polynomials fx equal to 1, fx equal to x, fx equal to x squared, and fx equal to x cube. And we'll get finally four equations involving alpha, beta, gamma, delta, and then we finally solve this problem. Okay, but you may ask one thing, that why we choose fx equal to x squared particular polynomial. The point is that instead of x squared, you can consider 2x squared in any way, but you will get the same thing, because choosing a particular f doesn't matter. The point is that you need to get four equations involving alpha, beta, gamma, delta. That's why you can consider four polynomials of different degrees. So finally, you will get four polynomial, and after solving this polynomial, you will get the value of alpha, beta, gamma, delta, and that's what I have done the solution. Okay. So the final answer is 20. So this integer 9 times of alpha squared, beta squared, gamma squared, delta squared is 20. So that is the solution for this problem. Thank you.